Hello, welcome back. Today we are discussing about the application of fundamental deviation and grades of tolerance. The fundamental deviation is defined as the deviation among the upper and lower deviation which is nearer to the zero line. According to Bureau of Indian Standard, that is BIS, there are 25 fundamental deviations, and each fundamental deviation is represented using alphabets, English alphabets from A to Z, and we are using these capital letters A to Z for representing the whole fundamental deviation, and the small A to Z is used to represent the fundamental deviation of shafts. The delta F stands for fundamental deviation, and for whole we are using fundamental deviation like this, and in this A to G is used A, B, C, C, D, D, E, E, F and F, G and G. These are used for getting clearance fit, and the H is the basic hole, that is in the whole basis system. Capital H is taken as the basic hole, so that is fixed for whole basis system. And then J, K, M, N, these are Mn up to N is used for transition fit, and the letters P to ZC are used for getting interference fit. Similarly, for shaft, these all letters are replaced with the small letters, and here we can see that this A to G, these are in the opposite side of the zero line for a shaft, and this A to G is for getting clearance fit, and the small h is there here, the small h which is used as the basic shaft if we are going for shaft basis system. Then J, K, M, N are used for transition fit, and the remaining P to ZC are used for getting the interference fit. From this picture, we need to recall the position of each range. First is for whole, it is A to G is above the zero line, and then H2, H and JKN, JKMN are for transition fit, that is very near to the zero line, and P to ZC are below the zero line. Similarly, for shaft, there are also having some relative positions. So these relative positions should be in mind while designing a fit. Next is grades of tolerance. Grades of tolerance is nothing but we have got a tolerance zone like this, both for hole and shaft, and the width of this tolerance zone, that is the tolerance in microns, is the actually it is represented with the grades of tolerance. Again, according to BIS, we have got 18 grades of tolerance, and these tolerance are represented with the capital letters IT, that is that stands for international tolerance, and it starts with IT01, then IT0, then IT1 to 16. So it is total 18 grades are there. So these different grades are given for different applications or accuracy levels. So for measuring instruments, we are giving a tolerance grade of some 0.010 and up to 7 is given for measuring instruments, and normal fits, the fits of a hole and shaft in normal working, we are using tolerance zones of tolerance grades of 5 to 11. Then for large manufacturing tolerances, that is less precise work pieces are given with grades with 12 to 16. Here it shows the representation of this fundamental deviation and tolerance grade for a dimension. So first we will consider 50 H8, and this since H is a capital letter, so we can tell that this is a representation of dimension of a whole, and 50 is the basic size, and H is its fundamental deviation, and the grade is 8. Second one is 50 small f8 7. So here it is small f is used, so this is a dimension of a shaft, and 50 is the basic size, small f is the fundamental deviation, and 7 is the IT grade. And finally, this is the representation of a fit. So in here we are using 50 H8 bar F7. Sometimes we are using a bar and sometimes we are using a hyphen. Okay, then 50, first we will give the fundamental deviation and grade for the hole, and later we are giving it for the shaft. So here it is represented like this. 50 is the basic size, H8 bar F7. So this one is now the representation of a fit. Referring to this chart, we can tell that what kind of fit that is. So the 50 zero line will be drawn as a straight line, and we know that capital H is the basic hole, so it is resting on the zero line. So this is represented the H, capital H. Then we will go for the small f. So from that chart we know that the small f is below the zero line, and this is small f, and this is for shaft, and this is for hole, and this is shaft. So from this graphical representation we can tell that the size of the shaft is smaller than size of the hole. So this kind of fit always result in a clearance fit. For determining the value of grade from IT01 to IT16, we are using equations like this. So based on these equations, we are finding what is the grade in microns. And here the most important grades are starting from IT5 to IT16. So IT5 to IT16, IT5 is there. We have to use this equation is 7i. Then next for IT6 it is 10i, and so on. So we needed to find what is this I. So I is given by this equation. I is equal to 1 by 1000 into cube root of 0.45d plus 0.001d. And in this equation, 1 by 1000 is used for converting it into micrometers. The final answer will be micrometers. And d is if 1 by 1000 is using, we have to we can substitute this d in mm. Then d is not basic size. D is determined by an equation, that is the geometric mean of two diameters, that is d max and d minimum, and it is given as d is equal to root of d max d minimum. The d max and d minimum will be getting from a table for basic sizes that will be discussed in the next slide. Now this is the table for basic size. So first we have to determine what are the lower limit and upper limit of the range in which our basic size includes. For example, if 35 is our basic size, 35 mm, we know that it is between 30 and 50, and we have to take d minimum as 30 and d max as 50. So instead of 35, the d is determined by root of d max into d minimum. Then if our basic size is 30, then what we will choose, because 30 is actually in this range, 18 to 30 it is available, and 30 to 50 it is available. So which one we will take? So the reading of the chart is like that. If it is 18 to 30 means it is above 18. Okay, it is not including 18, above 18, that is it is starting from 19 and up to and including 30. So 30 is actually included in this range, that is 18 to 30, and 30-50 is means it is above 30 to 50, that means 31 to 50. And that is the way of reading this table. This chart shows the equations for fundamental deviations of shaft up to 500 mm, and the fundamental deviation of shaft is started with the small a and it is up to small zc. So all fundamental deviations have got different equations, and these equations are applicable to find the fundamental deviation of shaft, assuming that we are following the hole basis system. So only one hole is used, that is the capital H. So we don't need to determine the fundamental deviation of capital H because it is resting over the zero line. So the fundamental deviation of hole in hole basis system is 0 only. So only we needed to determine the fundamental deviations of the shafts for different fits, whether it is a clearance fit or a transition fit or interference fit. In this equation also we are using a letter D. So here also the letter D is not representing the basic size, but it is representing the geometric mean of D max and D minimum. Thank you for watching.